Hi, my name is Annalisa Benitez, and I am from Florida. I am 17 years old.
And I'm Ori Ben-Gur, from 15 years old, from Israel. And today we're going to be presenting our project, Space Debris Collection and Recycling. So our project focuses on two goals. The first is space debris collection, and the second is recycling the debris into useful materials that can be used in space. Throughout this presentation, we'll talk about why this is important, how our collection system works, and how recycled materials can support future missions.
So, as we've heard a few times, there's a lot of problems in space, and space debris is one of them. And it is a threat to our satellites as well as future satellites, as it might hit them or dent them. Currently, there's about 40,000 objects, both metal and non-metal, orbiting Earth, and only 11,000 of those are active. Even a piece of paint could hit a satellite and dent it, so this is a big problem. And that's also 9,000 metric tons of material. This diagram here shows in the light blue halo fragmentation debris, which is the largest section of debris out there. But there's also several other types of debris, and all of them together form a large part of objects orbiting Earth. The mission that we are trying to achieve is to collect that debris, turn it into something that can be used again, and give it to someone who can use it, such as the organization that previously launched it.
So, one of the biggest benefits of recycling space debris is reducing the amount of materials that have to be launched from Earth. If materials are already available in space, future missions would require fewer supply launches, and except for food and other essentials. So it could also reduce launch costs and make missions much more efficient. Satellites could also be eventually built in space using reused materials. Recycling debris also reduces the need to mine more raw materials, making future space missions much more sustainable. Removing debris makes low Earth orbit safer. There is also a lower collision risk and easier navigation through low Earth orbit. Our proposed solution is multiple autonomous debris collectors. We have four main objectives: identifying the debris, collecting the debris, transporting the debris to the recycling center, and repeating without human control. Our software uses information from online tracking databases with onboard navigation systems for spacecraft location relative to debris. It then guides the collector to the target. For our hardware, we have one large thruster for forward movement and four smaller ones for directional control. The solar panels provide power for the onboard systems, utilizing GPS position and tracking. To capture debris, our collector uses a reinforced net before transporting it to the recycling center. This slide shows step-by-step how our net intake works. So first, the process begins by the jaw opening, and then it releases the reinforced net onto the item, then it catches the item, then it pulls in the item, and then it closes the jaw. By repeating these steps, the collector can gather pieces of debris before delivering to the recycling facility. We're still evaluating which propulsion system would be best for this. So, before choosing our design, we compared different methods. Magnets require little energy, but only collect metal. They're also very expensive if you want a very strong magnet. Drag cells are lightweight and passive, but only work in very low orbits, and they have long orbit times and provide no active control. We also thought of attaching a thruster to the debris and reversing its motion. It can slow the debris quickly, but attaching the thruster is very difficult, and spinning debris makes it even more challenging. We also thought of harpoons, which provide strong mechanical connection and are good for large debris, but they need extremely accurate targeting and carry the risk of fragmenting the object. It can also raise political concerns because of its look as similar to a weapon. Finally, we selected the reinforced net. It can capture multiple objects, is relatively inexpensive, and works with many types of debris. It could be pulled backwards, but it'll be fine thanks to the forward thrusters.
The next thing is after we collect the debris, we need to recycle it. We need to turn it into materials that our astronauts and anyone in space could use. For that, we need to separate the debris, sort it, recycle it, and return it back to its original owner. For the separation method, we're thinking of using a robot using artificial intelligence that can separate the debris using robotic arms. This will be similar to the automatic robotic dismantling and disassembly system being developed at Akron University or RoboLoop from Carnegie Mellon. For sorting, we are thinking of using a conveyor belt system to separate metals, processing units, plastic, and carbon-based materials. The metal will further be separated by imaging identification and conductivity, while the plastic will further be separated by triboelectrostatic separation. Here's a diagram where we better show how the debris will be separated. Or sorted, I should say, sorry. The debris will first be separated via conductivity to conductive and non-conductive materials. Then the conductive will be further separated using imaging to separate processing units from normal metal. The metal will then be further separated using conductivity again to separate into different types of metal, and then steel will be further separated by magnetism. The reason why we're further separating steel is because different steel alloys have different properties, and we think that the owners of this material would find it useful to have these different properties available to them. The non-conductive components will go through triboelectrostatic separation, which is a simple way to separate different types of plastic, and it requires much less resources as some other separation methods, making it the most I want to say the easiest method to achieve in space. Then we need to recycle it. So metal can be left as is and give it to the organization because they may choose to use the metal as it already is, or they may choose to melt it down and use it in metal 3D printers, which are currently being tested on the ISS. Electronics will also be left as is, but this is because electronics are very fragile, and we want to make sure that we don't damage the electronic components with a machine, so we want humans to take them apart manually. Carbon-based items will also be left as is because we don't have a way to recycle them all the different types of carbon-based materials in the same fashion. But plastics are to be determined, and we have a few different ideas. So our first idea is to turn plastic into a polymer resin that can be used in 3D printers, such as the ones currently being developed by Redwater Space. A second idea would be to use a strain of E. coli that's being engineered at the University of Edinburgh to turn the plastic into paracetamol, which is a helpful drug that helps reduce fever and pain. The last idea is to turn the plastic into some sort of fuel via pyrolysis. Pyrolysis can turn plastic into byproducts such as gasoline, kerosene, diesel, benzene, toluene, and xylene. This is a QR link where you guys can tell us what you think is the best idea for us to do, as well as input any of the ideas that you guys have on what we should do with our plastic. Or like most of you. So please give some input. We good? Yeah? Okay, perfect. The next thing I'll talk about is laws in space. So there's not a lot of laws concerning who owns what in space, but one of the main laws is the United Nations Outer Space Treaty, which kind of mirrors maritime law in the sense where the object that's launched is under the jurisdiction of the person who launched it. This specific treaty lacks the nuance of multi-party collaboration, which should be further tweaked in the future. Some treaties that we suspect will come to play are some ocean treaties such as the International Convention on Salvage, which is where states had to give compensation for the recycling of their wreckage and the returning of their wreckage. The Nairobi International Convention on the Removal of Wrecks forced companies to recycle or remove their pollution if it was deemed hazardous to their environment. As you can't tell, debris is pretty hazardous, so. But we think that the best way to use the laws to our advantage is to make deals with specific organizations, states, or countries, in which we ask them, can we salvage your debris for a little bit of pay? In this scenario, we have individual salvaging, which is where they ask us to salvage one specific piece of debris, and complete salvaging, which is where we salvage all the debris that they have released into space. A treaty similar to the Nairobi International Convention on the Removal of Wreckage would help push organizations to pay for this salvaging. In the end, it's beneficial to clean up space because it will save future money on future launches as we have new materials to use. It will increase sustainability, and it will become easier to navigate LEO. We believe that the space collector will be an autonomous machine that can retrieve this debris, and the net is the best way to have this debris retrieved.
Once collected, the debris can be separated, sorted, and recycled into materials that will be reused for future missions. We also believe this concept can become economically practical by providing debris collection as a service to organizations instead of attempting to remove all the debris at once.
Any questions?
Woo.
Thank you.
Thank you for this very brilliant expose. I have two questions. Both of you, in which grade are you? First question. Second question, have you conducted a cost analysis of recycling?
So I am a rising senior.
Going into 10th grade.
And though we haven't assessed or made a cost analysis, we are basing this off of hypothetical numbers because we don't have a secure database to use. If you guys have some databases that we could use, I would love anything you could give us, but we don't really have stable numbers to go off of.
Thank you.
Thank you for the brilliant presentation. I think you've inspired us all. I'm curious whether the recycling centers would take place in space or if these would be brought back down to a recycling center on Earth, or whether you've thought about both possibilities.
Okay. So the recycling center will be placed in space because the goal is to not bring the materials back down to Earth, but to reuse them in space. This reduces the cost of transporting them back to Earth and then launching them back up again. Instead, we can just create new of satellites essentially in space using old satellite components.
I admire your enthusiasm greatly, and I believe that dealing with the debris problem is a very crucial one. I guess my question is, do you feel that everyone knows who the owner of each piece of debris really is, and therefore there can be attribution and collection of resources from people?
Okay, so it's hard to identify what each piece of debris is from, but there are several ground stations that are currently doing research on trying to identify what each piece of debris is. If we can figure out what type of debris it is, we could try to figure out what type of debris it comes from. So while we don't have the knowledge right now of what each piece of debris is, we believe that research on ground stations can get us that answer. Yes.
Thank you. We thank our speaker. We leave the question for the coffee break. We move now to the last presentation for this session, given by Victoria Valdivia.